What happens if your spinal cord is cut in half? Let's look at the Brown Sequard syndrome. This is your friend Dr. Devesh Bhatt, and this is part 10 of episode 11. And let's get this started. So let's put all the tracks that we have studied in the previous parts together in this one single diagram and make it easier for us to understand. And let's start with the sensation of pain and temperature, which are carried by your lateral spinothalamic tract. So for example, let's take this left lower limb of yours. So the sensation of pain and temperature will be carried by your first order neuron towards your spinal cord. But just before entering your spinal cord, it will give a relay in your dorsal root ganglion, and then it will enter the spinal cord via your dorsal horn. Now, because we are talking about the pain and temperature here, they will give synapse to the second order neuron in the nucleus substantia gelatinosa and nucleus proprius. Okay, and from here, the second order neuron of the lateral spinothalamic tract will start. The second order neuron of the lateral spinothalamic tract now here will decussate, cross over, and go to the opposite side of the spinal cord. And from here, it will start ascending upwards towards your thalamus. And where in the thalamus? They will go to the ventero-posterior-lateral nucleus of the thalamus, where they will synapse to the third order neuron. And from there, the third order neuron will take the sensations of pain and temperature to the somatosensory cortex area of the brain, which is located in the post-central gyrus, denoted as the Brodmann's area number 3, 1, and 2. So this was about the lateral spinothalamic tract, and it was decussating at the spinal level itself. So let's talk about the other sensations like fine touch, proprioception, stereognosis, graphesthesia, tactile stimulation, and tactile discrimination. All of these sensations are of your dorsal column or of your dorsal column tract. Okay, so for example, all these sensations from the lower limb, they are carried by your tract, which is known as fasciculus gracilis, and the same sensations they which are carried from the upper limb, they are carried by a tract known as fasciculus cuneatus. So fasciculus gracilis and cuneatus both together forms your dorsal column tract. Okay, the dorsal column tract will ascend upwards ipsilaterally without crossing till the medulla. In the medulla, it will synapse with the second order neuron of the dorsal column tract in the nucleus gracilis and nucleus cuneatus. So the second order neuron of the dorsal column tracts here in the medulla will decussate and go to the opposite side. And from here, it will again start ascending upwards towards your thalamus. And where in the thalamus? They will ascend upwards towards the ventero-posterior-lateral nucleus of the thalamus, where they will synapse to the third order neuron. And the third order neuron will take all of the dorsal column tract sensations to the somatosensory area of the brain, which is located in the post-central gyrus. So basically, in the post-central gyrus, you have sensations from all over the body, which are coming to that, which are coming to the post-central gyrus to the somatosensory cortex area of the brain. And from here, the brain will process the information and give out the motor output that you have to move your hand from here. So this motor output is given from the primary motor cortex area, which is located in the precentral gyrus, denoted as the Brodmann's area number 4. All of this we have discussed in the previous parts. So from here, the upper motor neuron will start descending downwards, okay, forming corona radiata, then the posterior limb of the internal capsule coming to the medulla. Here, the corticospinal tract will form pyramid-like structure, and that's why the corticospinal tract is also known as the pyramidal tract. Now, this tract here in the medulla, 80 to 85% of the tract, 80 to 85% of the fibers of the tract will decussate and go to the opposite side, forming your lateral corticospinal tract. And those 10 to 15% who doesn't decussate and keeps on going downwards ipsilaterally forms your anterior corticospinal tract, which gives the motor innervation to the muscles of the axial muscles of trunk. And those 80 to 85% which have decussated went to the opposite side, they become the lateral corticospinal tract. They starts moving downwards, they descend downwards, they go to the anterior horn cell, where they synapse with the lower motor neuron, and the lower motor neuron will take the information, the motor innervation, and then supply it to the muscles, the distal muscles of your limb, allowing you to control your hands and feet, do fine voluntary movements. So this was the function of your lateral corticospinal tract. So basically there were two tracts that were decussing at the medulla. At the level of medulla, there were two tracts that were decussing. One was your dorsal column and another was your corticospinal tract. Okay. So the funda that you have to remember here, that whenever you have a lesion, which is above the decussation, the loss of function that you will observe will always be on the contralateral side of the body. And the lesion, if the lesion is below your decussation, the loss of function that you will observe will always be on the ipsilateral, that means on the same side of the body. Now let me give you a good easy example of the brain itself. If you have a lesion in your brain in the left side, let's consider that you have a lesion in your somatosensory cortex area of the brain in the left side. So on the left side, from where all the fibers are coming from, the sensory fibers, they are coming from the right side of the body. So whenever there is a problem in the left somatosensory cortex area of the brain, the loss of sensations from will be felt from which side of the body? It will be felt from the right side of the body. Another example, if you have a problem in the left side primary motor cortex area of the brain, okay, from the left side of the brain, where these fibers are going to, they are descending downwards in the medulla, they are crossing over to the right side, and they are supplying to the motor muscles, the muscles of the right side of your limbs. So that's why there will be loss of motor movements from the contralateral side of the body. Understood? So now let's look at the hemi section of the spinal cord and what happens in Brown Sequard syndrome. Brown Sequard syndrome is nothing but the hemi section of the spinal cord, and hemi section means half of your spinal cord is damaged. In the half section of spinal cord, you have all the tracts. You have dorsal column, you have lateral spinothalamic tract, you have corticospinal tract. So basically, but because it is in the spinal cord, for example, this is the site of hemi section. Just consider that this is a site of lesion where your spinal cord is damaged on the right side. So we have right side damage of the spinal cord. But we already discussed that two of the tracts were already decussated up in the medulla. They were corticospinal tract and they were the dorsal column. So now whatever loss of functions that they will show will be seen on the ipsilateral side. So if we have the injury on the right side of the spinal cord in the Brown Sequard syndrome, we will have ipsilateral loss of sensations like fine touch, graphesthesia, okay, stereognosis, and also loss of voluntary control of muscles. They all will be from the ipsilateral side of the body. Now let's see from below downwards which tract was there which was decussating below, means at the spinal level. If we have the hemisection of the right side of the spinal cord, the lateral spinothalamic tract will decussate 2-3 spinal levels below, the lesion. And that's why if we have a right side lesion of the spinal cord, right side hemisection of the spinal cord, the loss of pain and temperature that will be observed will be on the contralateral side of the body, So just to revise, if we are having a right-sided lesion, right side hemisection of the spinal cord, which is damaged which is known as the Brown Sequard syndrome, we will have ipsilateral. That means on the right side itself, we will have loss of sensations of fine touch, proprioception, graphesthesia, stereognosis, tactile stimulation, tactile discrimination, and also loss of voluntarily control of your muscles. That will all be lost on the right side of your body ipsilaterally, and on the left side, that means on the contralateral side, you will observe loss of pain and temperature. if we have a right-sided hemi section of the spinal cord, and basically this is nothing but your Brown Sequard syndrome. Thank you so much, and I hope you have liked this video. I have tried to make a very difficult topic easy for you guys to understand. So if you are the one amongst those guys who has watched such a long video up till here, and if you are really liking my efforts trying to simplify difficult topics for you, please keep going in the comment section down below. It will motivate me to do better and bring better content for you guys. And also, if you have some topic for me to explain it to you, please also mention that in the comment section down below. This is your friend Dr. Devesh Bhatt signing off. Shukran, alvida, ma salamat, take care and do whatever you want. My lovely friends, see you in the next video.